So what is meant by module? Hmm? You know the coherent system, the concept of coherent system. You can see several structures of some electronics or electric mechanical systems. Hmm? Uh, in this system, yeah, let us look at this. Let us look at this section. TX laser, IQ modular, simple decision. So all these units are modules. Okay, these are all another picture representation modular system. So these are representation in electric area. So what is actually a module? You know that in DRDO. Do you know DRDO? DRDO. Have you heard about that? DRDO, Defense Research Organization. കേട്ടിട്ടുണ്ടോ DRDO? Defense Research and Development Organization. In this DRDO, you can see that this is a DRDO website, and some of my relatives are working there as electrical engineer, mechanical engineer, I think computer engineer. My relative, she told me that they are developing the missiles and parts of the missiles. So what is the need of parts for the missiles? The entire agency are not giving the entire system for the development. They are giving the project for preparing parts. For example, radar system, or you can see several activities of DRDO. Another module may be my relative is preparing. My relative is a part of the team who is preparing this radar system. Okay, in the missile technology. Okay, so and another module may be the engine part. Maybe another module, and another module may be what is that, fuel section. So all these after assembling using these modules, it will become a perfect missile. Okay, so what is the need of preparing this type of modules by different groups? So the entire idea should not be shared with each other, because the spy work may be happen. So to avoid such situations, this type of security machines, they will prepare all the modules by different units. Okay, so in this if you go through this DRDO website, you can see this is technology clusters is there. So you can see different activities of this DRDO. So I told you because in a system engineering, another example is look at the computer system. Okay, you can see that your computer may be by the company of Acer or by the company of what is that, Dell. Your computer may be what is Compact, etc. So there are different company names. At the same time, you can see that a computer or a laptop is made up of as an assembly system of CPU, what is it, keyboard, and SMPS, and what is that, processor, etc. So there are several submodules in a computer system. Okay, actually in most of the computers we can see that the Core i3 or Core i2 or Core i4, that is Intel processor. The Intel company is preparing only the processor. They are not preparing the computer. At the same time, in every computer, in most of the computer, we can see that the processor is Intel Core i3, Intel Core i5, or etc. Another component will be webcam or display, 15.6 HD display. So that may be prepared by another company. Okay. Another is Wi-Fi Bluetooth network connection. So everything will be prepared by different companies, and it will be assembled by Acer or Dell or HP or etc. So the company is doing only assembly work. Okay. So the Intel Core processor is actually available in most of the computer. At the same time, the computer name will be either Dell or HP or Acer or etc. So any system can be considered as it's a assembly what's that? It's a configuration of different modules. Okay, maybe in that modules may be in parallel, modules may be in series, or modules may be in series parallel or parallel series, etc. Okay, so we have to study. So we have to study about the modules of a coherent system, or the system with the modules. So that is a important area in the reliability theory. Okay, so let us consider a system consists of n components. Okay, a system consisting of n components. Here you can see that an example of system with the 3 modules. So what are the modules? First one, the component 1 itself constitutes a module, and the second module will be, I will draw that picture, no problem. Second module will be the subsystem consisting of 2 and 3. Okay. So this is the first component, this is the second component, this is the third component, fourth component, fifth component. Okay, so let us denote with x1. This is the state of the first component. This is x2, state of the second component. x3, state of the third component. x4, state of the fourth component. x5, state of the fifth component. So what will be the entire system structure? What is the entire system structure? Phi of x1 comma x2 comma etc. x5 will be equal to, you can frame that structure function. What will be the structure function? x1 into x2 union x3, okay, into x4 union xy. Am I right? I think this is the structure function. Okay, so so this is the system we are considering, and this is the structure function. Okay, now look at the different modules. So what are different modules? Hmm? This is a module. Okay, in this module we have only one component. Okay, that is x1, and this is another module. Okay, in this module we have two components that are connected in parallel, that are x2 and x3. Okay, in this module we have two components and they are connected, also they are connected in parallel. So we can consider these three modules are three subsystems. And what is the structure of this first module? What is the structure of this first module? Just x1. Okay, what is the structure of this second module? x2 union x3. Okay, what is the structure of this third module? x4 union x5. Okay, so we can divide the entire system into different modules and we can separately compute or construct the structure function for the modules. So this is the idea. And after constructing this module or after preparing these modules, we can connect these modules in series. This is first module. This is second module. This is third module. Okay, that we can connect in series. Okay, they are connected in series. We can use the notation. Let us look at this notation they have used. Yeah, chi1. Structure function of this module is chi1. How can I write chi? Okay, let me denote it as h1. Structure function of this module is h2. Structure function of this h3. Okay, so this h1 and h2 h3 are in series. So what is the system structure? Yeah, system structure will be h1, h2, h3. Okay. The entire system structure will be h1 into h2 into h3. Okay, so that is the idea we are using. So the entire system can be divided into different modules and we can connect either in series or in parallel. That constitute the entire system. Okay. Okay. So that is the idea. Yeah. So the coherent system A comma chi is a module of a coherent system C comma phi if phi of x equal to psi of, okay, I will write in this in word format, no problem, so that you can easily understand the concept. I think it will be visible in your WhatsApp group. I have sent us that page. You can use that WhatsApp. Okay. What is that? Yet considering the coherent system A comma chi. I think chi is available. I will put. No, it is not available in this. insert symbol. I think we have to put symbol from here. Yeah, it is available. Chi a comma the coordinate system a comma chi is a module of the coordinate system. If so, we can say this has the module of a coordinate system. That means let it be a1. Let it be a1 module a1. You can choose a different color. A1. This is A1 module. This is A2 module. A3 module. A1 consists of, what is the set corresponding to A1? Only one. A2 consists of components 2, 3. A3 consists of components 4, 5. Okay. So that is so a comma chi. So the corresponding structure is at 1, at 2, at 3. Okay. So instead we can use chi 1. The structure of this is chi 2. Chi3 equal to x3, x4 union x5, and chi 2 equal to x2 union x3. So that is a situation. Okay. So, and moreover we should have, what is the, so we can say chi 1 is a1 is a module. A1 is a module. This structure function chi 1, if we can represent, if we can represent the structure function. What is the structure function? Structure function phi of x can be represented as in this example it is series psi of psi is very psi, yeah, psi of, that means in our case it is series psi of, what is that, chi of a, or it can be a1, can be a1, and what is the representation, x chi of xa, chi of xa, xa is, the notation is chi of xa, x in a, a1, and x in a1 complement. Okay. Okay, that means we are considering x in a, that means in this case it is x1. So x1 comma x1 comma x2 x3 x4 x5. So that equal to what is that? Okay, there is a notation only. Okay, instead of a1 we can use, so in this case we can say a1 is a module. Similarly, we can find out, we can say A2 is the module if we can put like this and so on. So that is the idea. So in this case, A will be a subset of entire set, because in our first case we have A is equal to 1 only. So that is 1 is a subset of 1, 2, 3, 4, 5. C is equal to 1, 2, 3, 4, 5 in our example. So okay. So this is the, so A comma chi is said to be a proper module if it satisfies this condition. So in our example, 5 component system, we have A is equal to 2 comma 3. In this example, A is equal to 2 comma 3. If we consider A equal to 2 comma 3, that is second module. Okay. Then what will be the structure function of second module? The structure function will be, structure function will be x2 union x3 is the modular coherent subsystem. So in this case, we when we consider second module, what happens? In this case, what happens? So this will be some, how can we organize this one? This can be written as, x1 into, what is the components in second module? A2, 2 and 3. What is the structure? Chi of 2 comma 3. Okay. Now what about the remaining structure? X4 union X5. So we substituted the structure function of the second module. So that is, so entire system can be represented like this. So that is mentioned here. Okay. So similarly, we can find out the, what is the structure in terms of remaining modules, and that information are given here. So we can formally define the modular decomposition of a coherent system as we seen in this definition. A modular decomposition of a coherent system C comma phi is a set of disjoint modules A1 comma chi 1, A2 comma chi 2, as we seen in this figure, A1 comma chi 1, A2 comma chi 2, A3 comma chi 3. Okay. Together with the organizing structure psi. The organizing structure is psi. So C will be the entire set that consists of union I from 1 to n AI. So in our example, x1 A1 1 union 2 comma 3 union 4 comma 5. So we will get C equal to 1 2 3 4 5, and phi of x equal to xi of chi 1 of, so the entire system. So instead of writing this one, we can write once again we can write in a different way. That is phi of x equal to, this will be chi 1, this is chi 2, and instead of this we can write chi, not chi, maybe psi x a3, x in a3, or x raised to a3. So this is first module structure, this is second module structure, this is third module structure. So the entire system can be represented as series connection of modules. So that is the idea is given here. So phi of x can be represented as psi of chi 1 of x raised to a1, comma chi 2 of x raised to a2, etc., chi p of x raised to ap. So that is the definition. So in this case we can say a modular decomposition of coherent system is a set of disjoint modules a1 comma chi 1 etc. ap ar comma chi r together with an organized structure psi, and which satisfy these two conditions. Okay. So after this you can read this also. After this you write and submit today itself. Do not postpone for tomorrow. You may submit today itself. Okay. So I think we can stop today's session. So the final word, let me talk about the DRDO units. In a similar fashion you can see Baba Atomic Research Center, BARC. In BARC also they are preparing different modules because of security. In every engineering system we can see modules. We can see the reliability analysis of modules. Every engineering system, not only the computer or phone or whatever be the engineering system they are considering. Yeah, these are different modules. Okay. You can have different type of reports from this website as a good example for engineering systems. The different modules. They are preparing different modules. They have given the display here also. Okay, it is actually this reliability theory is a beginning of some application of statistics in engineering. A wide application is there in engineering by the use of statistics. So reliability theory is a special example. Okay, so you can study reliability theory in detail so as to apply the statistical theories, statistical ideas to the engineering activities. Okay. Yeah, you can see a book by Advances in Performance and Safety of Complex System. In this book, one of the chapters is my research activity. My one of the chapter in my research thesis, it is published in this book. This book is actually the papers presented at International Conference on Safety, Quality, Safety and Reliability during 2008 at Baba Atomic Research Center. So at that time they have accepted our paper for the presentation, and they have published in this book. I spent 3 days there in Bark with this reliability conference. Okay, anyway, let us stop here. Thank you very much. ബാക്കിയുള്ളവർ എവിടെ പോയി?